Okay, so today we are picking up where we left off yesterday. We're going to take those growth and decay functions and we're going to use them to model real-world situations. So the first one we'll talk about is an exponential growth model. It's just given by the equation y equals a times the quantity 1 plus r raised to the t power. This 1 plus r, this thing that's being raised to a power, that is your growth factor. So if it ever asks you what the growth factor is, it's 1 plus the rate. All right, so what these things all stand for. Y is just the amount that you have after t years. And A is your initial amount, what you started with. R is the rate of increase. And T is time in years. Yeah, it's always going to be in years with this equation. You could conceivably do it for different time periods. It just, the problem would specify it, and you would maybe use, say it was W if it was weeks, or, you know, maybe use a different letter. But yeah, typically it's years. But that's not saying you won't ever run into a problem where it's something different. Because for instance, like bacteria, they'll do bacteria growth usually in terms of like hours even. So you would maybe use H instead for hours. Yeah, you would. If it was half a year, you would just use 0.5. Yeah. Okay. All right. So the main thing, what I see most often as an area where people make an error is they forget that when the rate is given them as a percent, they need to turn it into a decimal. Okay? So that's important. Don't forget to turn your percent into a decimal. If you think about it, percent, the word percent just means per 100. So if I have 3.5%, that means I've got 3.5 per 100, or divided by 100. So to convert it, you just move the decimal over 2 places. I'm sure most of you probably already knew that. But okay, so that's really important that you don't forget to change your percent into a decimal. All right, so let's take a look at a sample problem. In 1996, there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased approximately 92% each year. Write a model and determine approximately how many incidents occurred in 2003. So the first thing I'm going to do is just write my model, okay? And I'm going to use that equation. I'm going to take the information that they gave me up here, 2573 computer viruses in 7 years and about 92% each year. So let's figure out what each of those things are. So my 2573, what is that? Which one of those letters up there? Which one is it? It's A. It's the amount we started with, right? And then 7 years is my time, T. And then there's my rate, but I have to turn it into a decimal. So what is it as a decimal? 0.92, yeah. Okay, and so then it's just a matter of plugging it in. So for the initial model, I'm still going to just have it say T, because a model is something that you can use for any time period. So the model would be y equals 2573 times 1 plus 0.92 raised to the t power. And then you can just simplify what's in the parentheses, add them together. We end up with 2573 times 1.92 to the t power. So my growth factor for this is 1.92. Okay? So that would be my model. And then to find out how many occurred in 2003, that was 7 years later. So then you just plug in the 7 to the model. So y would equal 2,573 times 1.92 to the 7th power. So in a calculator, most of the calculators these days, unless you have a single line calculator, but if you have like one of the 2-line scientifics, you can usually just put in exactly as you write it down. 2573 times 1.92, and then we raise that to the 7th power using the caret button. So I want to make sure you guys know how to use your calculators. So if you have a calculator, get it out. If you don't have a calculator, come borrow one of mine. I don't want you using your phones, okay? Use a real calculator. So do I have a brave soul out there that would like to tell me what they get when they put that in their calculator? Raise your hand if you are feeling brave. All right, Lexi.
2, 4, 7, 4, 8, 4.7.
Okay, and since we aren't worried about fractional incidents, we'll go ahead and just round it to a whole number. So approximately 247,485 incidents. That's a lot, isn't it? Yeah. Well, that's what happened when the internet took off, I guess. Okay, so was everybody able to get that number to show up in their calculator? Anybody need help with it, or are we all good? Okay. All right, so now a specific type of growth model is compound interest. So this is just a variation of that formula that we just learned. What we've done is we've added in the number of times that something is compounded. So compound interest is when we're talking about like money that we put in the bank, or it could also be money that you borrow from the bank also. So A is going to stand for the amount that's in the account after T years. And then P stands for principal. The principal is how much money you put in the bank, the initial amount. Or again, in the case of a loan, it's how much money you borrowed. R is your rate. Again, it has to be as a decimal. And so what's new here is N for the number of times it's compounded in a year. And then finally, T is the time in years. So when you see these, you might see that something is compounded quarterly. It might be compounded monthly. It might be compounded bi-monthly, daily. If it's done quarterly, how many times a year do you think that is? 4 times a year, right. And if it's done monthly, that would be 12 times a year. And if it was done bi-monthly, what do you think that means?
24.
Yeah, 24 times. It's twice a month, okay? Or semi-annually would be twice a year, okay? Daily, how many times would be daily? 365 times, okay? All right, so the reason it's called compound interest is essentially you're paying interest on the interest that was paid before. So it's being compounded, it's being increased. So for instance, like if I'm like really lucky and I find a bank that actually pays 12% a year, that means 1% a month, right? So if I put $1,000 in there on January 1st and they compound monthly, at the end of January, they give me 1% of that, or $10. And so now I've got $1,010 sitting in the bank. So for the month of January, they're going to pay me 1% of $1,010. And so now instead of just getting $10, I get $10.10. And so on, and it just keeps growing and growing each month. So that's what's meant by compounding interest. It's that you're paying interest on the interest. Does that make sense? Okay. All right, so let's do a problem that involves compound interest. All right, we deposit $100 in an account that pays 2.5% annual interest. And we're going to find the balance after 30 years if the interest is compounded semi-annually. So my principal, that's my initial amount. What am I putting in the bank? $100. And what's the rate that they're going to pay me? 2.5%. But what do I have to do to that? Make it a decimal. So it's 0.025. And how many times a year are we going to be compounding? Twice, semi-annually. And then finally my time is 30 years. So you just take those things and plug it into the equation. So the amount is going to be 100 times 1 plus 0.025 over 2, and then that whole thing is being raised to the 2 times 30 power. So before I put it in my calculator, I'll go ahead and simplify it. 0.025 divided by 2 is 0.0125, so we end up with 1.0125. And 2 times 30 is 60. So in my calculator, I'm going to put 100 times 1.0125 raised to the 60th power. All right, so let's see here. Macy, did you do that? And what did you get for the amount? Okay, about 211. Since this is money, we're going to go ahead and do it to the penny. So 210 and 72 cents, exactly. Because yeah, the bank's not going to round up. They're not going to give you 211. They're going to give it to you the penny. All right, so $210.72. Just for sitting there doing nothing. Okay? So just depositing money one time and never adding to it, is that going to get you rich? Not really. If it's just sitting, I mean, it more than doubled in 30 years. But imagine how much more would be in there if you were putting $100 every month in. You'd probably be a millionaire. Okay? All right. Let's have you guys do one yourselves on whiteboards. So this is for you guys to do on your whiteboards. Okay. So when you plugged it in and simplified it, you should have ended up with 1.0073 to the 4th power, because we take the 0.0292 and divide it by 4 and then add it on. And so when you put that into your calculator, I think most of you ended up here eventually, 4,118 and 9 cents. Okay, any questions? Do you guys want to do one more like that? Okay, let's do one more. All right, so we end up with $5,909.97. Okay. So any questions so far? Nope. All right, so let's look at some decay. All right, so the decay model is almost identical to the growth model. The only difference is instead of adding the rate, now we're subtracting the rate. And again, this thing that's being raised to the power, the 1 minus r, now that's your decay factor instead of growth factor. So for example 3, we're going to have a new snowmobile that costs $4,200. The snowmobile depreciates 10% each year. We're going to write a model for the value y after t years, and then we're going to estimate the value after 3 years. All right, so everything is pretty much the same as it was in the growth. The A is the initial amount, R is the rate, T is time. And so if I look through what they told me, it costs $4,200. It's depreciating 10%. So whenever you see the word depreciate, that means it's going down in value. We're dealing with decay. And then after we do the model, we'll figure it out for 3 years. So my initial value was 4,200. That's my A. And 10%, if I make that into a decimal, it is 0.1 or 0.10, whatever you want to say. And then 3 years will be my time after I do my model. So let's do the model first. I just plug in what I know. So 4,200 times 1 minus 0.1 to the t power. And so if I simplify what's in the parentheses, it's 4,200 times 0.9 to the t power. And so again, my decay factor is what's in the parentheses there. It's 0.9. Okay? So that's the model that I could use for any time amount. And then if I want to find it specifically for 3 years, I just plug in a 3 for time. So 4,200 times 0.9 to the third power. So punch that in your calculators. Anybody want to volunteer and tell me what they got? Oh, I have to draw sticks now, huh? Not here. Leah, did you do that? That's correct, 3,061 and 80 cents. Okay. Anybody have a hard time getting that? We're all pretty comfortable with those calculators? Okay. All right, so now we're going to do that same problem, but we're going to change it a little bit. We're going to have the same snowmobile, so how much is it worth? 4,200. And now it's going to decrease by 20% a year. And then we're going to figure out what its value is after 2 years. So I'll let you guys do that on your whiteboards. Okay, it looks like most of you guys are getting it. The model would be y equals 4,200 times 0.8 to the t power, my decay factor being 0.8. And so then at 2 years, you plug in a 2 for the time, and you get 2,688. Exactly. Okay, so any questions? Pretty good on this then? All right, that's it for today.